Up until now, we've looked at the number system. We started off with um, counting numbers, which were one, two, three. Then we moved on to whole numbers. Start off with zero, one, two, three, and so on and so forth. Another name for those are natural numbers. I'm sorry. So the counting numbers are the natural numbers. Then we move on to whole numbers. Then we moved on to integers, which means we can have negatives, we can have zero, and we can have positives. And then we have rational numbers, which are decimals. As long as your bottom number is not equal to zero, we have decimals. And those pretty much define what we call the real numbers. All of these put together define our real numbers. But there are instances where we don't get real numbers anymore. For example, the square root works great if we have an even integer. Or we can use cube root. Square root, what times what is 4? It's 2. Cube root, what times what equals 8. That's 2. But we know from our graph that the graph of the square root, the radical, we cannot use negative numbers. The reason for that is because give me two numbers that multiply to equal 4. 2 times 2. There are no two numbers that are the same that equal negative 4. That multiply to give you negative 4. If we had negative 2 times negative 2, the negatives cancel, we get 4. And that's not the same thing as negative 4. So we cannot take square roots or radicals of negative numbers until now. Because in engineering, it does happen. Situations do occur when the numbers are logical numbers, they're legitimate, but when we put them in the formula, we do get a negative number inside there. So that's when they had to define what happens whenever you have a negative radical. That's what they define as I, imaginary number. So whenever you see a negative, for example, whenever you have a negative square root of negative 4, just take out the negative and put an I out in front. So now the square root of negative 4 is I square root of 4. Square root of 4 is 2, so the answer is 2I. So whenever you have any radical square root and has a negative inside there, take out the negative and put an I out in front, and then work out the number. So for example, if we had square root of negative 8, okay, automatically there's a negative in there, so we know there's an I. So we take out the negative outside from inside. 8 breaks down to 2 times 4. 4 breaks down to 2 times 2. So it's 2 times 2 times 2. Square root. The reason square root of 4 is 2 is because there are two numbers that are exactly the same inside there, I can take them out. So there are two numbers that are the same, I can take them out. So it's 2i. But this one still stays in there. So the square root of -8 becomes that. All right. So let's now look at what we can do with this. It sounds like an easy concept, but again, they make it hard for us. Example 1a. The square root of -7. If I give you that, again, you have a square root that's negative inside there, so it's an I. Square root of 7. As far as you can go, that's your answer. Because you can't do the square root of 7. It's not a perfect square. Square root of -16. The negative gives me an I out in front, so square root of 16. Square root of 16 is 4, so the answer is 4i. How about negative the square root of -13? Order of operations. We have to do inside the special operation first. So we have the negative stays out there. This negative becomes an I, square root of 13. That's as far as we can go. So if the negative's out in front, it doesn't cancel inside there. You cannot distribute that. Negative square root -64. Again, order operations. We have to do inside there. So this negative in front stays there. This negative comes out as an I. So we have square root of 64. So the square root of 64 is 8. Now, okay, I could have done this, but the common convention of mathematics is signs go first, then numbers, and then any letter. That's common convention of mathematics. And then the last one is square root of -48. So we have a negative. It comes out as an I. So we have square root of 48. What is 48 made up of? Let's break it down. We know that since it ends in an even number, we know 2 goes in there. 2 goes into 4 twice. 2 goes into 8 4 times. That's as far as that one goes. 24 is 2 times 2 goes into 2 once. 2 goes into 4 twice. 12 is 2 times 6. 6 is 2 times 3. That's as far as we go. It's called prime factorization. They can't go any further. So we have 48 is 1, 2, 3, 4. 2 times 2 times 2 times 2 times 3. 1, 2, 3, 4. Because it's a square root, we look for pairs of the same numbers. So there's 2 2's inside there. It comes out as a 2. There's another pair. It comes out. So there's I in front. And we left with square root of 3. So it's 2 times 2 is 4. I square root of 3. Okay. So that's the basic concepts and manipulations and moving it of it. Which now allows us to define complex numbers. They're called complex because it's not just a regular number. A complex number has this form, a plus bi, where a is a real number and bi represents the imaginary number because it has an I in the back of it. So imagine a complex number can look like this: 3 plus 5i, or -2 minus I. Is 6 a complex number? Yes, it is, because it has a 0 as a b value. Remember, a and b are real numbers, anything from negative infinity to positive infinity. So 6 is a complex number. It's also an integer. Likewise, -2i is a complex number because it's made up of 0 minus 2i. So any number can be written as a complex number. So now let's look at the algebra of complex numbers. Again, it's just what easiest way of saying, instead of saying algebra, all I'm really talking about is addition, subtraction, multiplication, division of complex numbers. So let's look at, first off, is the addition and subtraction of complex numbers. Example 2. 8 plus 6i plus 3 plus 2i. First off, do we need the parentheses? Since there's nothing in front of it, nope, we can drop the parentheses. Now combine like terms. 8 plus 3 is 11. Positive 6, positive 2 is positive 8i. So there's that answer. 4 plus 5i minus 6 minus 3i. There's nothing in front of the first one, so I could drop the first parentheses. But the second one has a minus sign, which means I have to distribute it to everybody inside there. So the negative times positive is negative 6. Negative times negative is a positive 3i. Combine like terms. 4 minus 6. 6 is bigger. The answer is negative. 6 minus 4 is 2. Positive 5, positive 3 is a positive 8i. Right, here's another way they can look. We're still going to do another example on the addition subtraction. I'll give it to you this way. Well, the first thing we do, order of operations, we have to do inside the parentheses. Can't do anything with the 4. So we have a negative inside the square root. That makes it an I. Square root of 9 is 3. So I rewrite that as 3I. Minus 3, negative 5. Negative 6, radical 16. So it's negative inside the radical. So it's an I. Square root of 16 is 4. So you can rewrite those first. Now get rid of the parentheses. I have to distribute. 2 times 4 is 8. Positive, negative is a negative. 2 times 3 is 6. I. Negative and negative is a positive. 3 times 5 is 15. Negative times positive is negative. 3 times 4 is 12I. Combine like terms. 8 plus 15 is 23. Negative 6, negative 12, they're both negative. 6 plus 12 is 18. I. So there's my answer. So that's addition and subtraction of complex numbers. How about multiplication of complex numbers? Okay, this is very important. This is very, very, very important. Well, the rule of radicals or exponentials says this: since these are both square roots and they're multiplied, I can combine them like this. True, except when it comes to complex numbers. Because if I gave you negative 2, the square root of negative 5, and you followed that rule there, we have negative 2 times negative 5. Negative negative is a positive. 2 times 5 is 10. Then you'll say the answer is square root of negative 10, or square root of 10. That's wrong. Because nowhere in the answer does it give us any imaginary numbers. What you have to do first, before you do any of this multiplication, is get rid of the negatives inside there. So these numbers here, it becomes I square root of 2 times I square root of 5. Now you can multiply them. We have I times I is I squared. Radical 2 times radical 5. I squared, radical 2 times 5. I squared, radical 10. Okay, here's a rule. You cannot have exponents on I. So what would x squared equal? Well, since we know that the square root of negative 1 is I, if we square both sides, the square and the square root cancel. So I squared is equal to negative 1. So whenever you see an I squared, all it does is multiply it. So this becomes a negative 1. So all it does is change the sign of the coefficient. So that's very important, is you can't just multiply negative, negative, get rid of those. So some examples here. A, square root of negative 16 times square root of negative 25. So here we have an I. There's a negative inside there, so it's an I. Square root of 16. I square root of 25. Get rid of the negatives. Square root of 16 is 4, so it's 4i. Square root of 25 is 5, so it's 5i. 4 times 5 is 20. I times I is I squared. I squared is the same thing as negative 1, so the answer is negative 20. Again, so in shortcut, whenever you have an I squared, just change the sign of whatever's in front of it. That's all it's going to do. All right, so let's look at if we had these binomials. We'll use FOIL technique. We'll multiply these out. So 1 times 1 is 1. Positive times positive is positive. 1 times 3 is 3i. 2i times are both positive, so it's 2i. Positive and positive is positive. 2 times 3 is 6. I times I is I squared. Combine like terms. 3 plus 2 is positive 5i. This I squared changes that sign to a negative, so it becomes negative 6. We have positive 6 times negative 1 becomes negative 6. Then we combine negative 6 plus 1 is negative 5 plus 5i. That's that answer. Then we have 3 minus 7i squared. 3 minus 7i times 3 minus 7i. So we have to distribute there. 3 times 3 is 9. Positive times negative is negative. 3 times 7 is 21i. Negative times positive is negative. 7 times 3 is 21i. Negative times negative is positive. 7 times 7 is 49. I times I is I squared. Combine like terms. So we have 9, negative, negative makes a negative. 21, 21 is 42i. This I squared changes that sign to a negative 49. Positive and negative. 49 is bigger than 9, so its answers would be negative. 49 minus 9 is 40. Minus 42i. So that's that one. All right, so that's multiplying and adding and subtracting. As the rule said, you cannot have exponents on i's. What if you had this, I to the 27th? Let's see how to fix that. We'll try to do this pretty quick. I'm not going to give you the formula. We're going to derive it. Since we know that I is just I squared is equal to negative 1. So that means I cubed is made up of I times I squared. That's where I cubed come from. I is I squared is -1, so it becomes negative I. So I cubed is negative I. I to the fourth would be I times I cubed. So we have I cubed is negative I. We have positive times negative is negative. I times I is I squared. Well, we have negative. We know I squared is -1. So negative of -1 is just +1. Let's do a couple more. So I to the fifth would be I times I to the fourth, which is I. I to the fourth we know is 1, so it's just I. I to the sixth would be I times I to the fifth. This is called inductive reasoning. Because of what we did in the past, we can use it in the next step. So we have I to the fifth we know is I. So I times I is I squared, which makes it -1. That's what I squared equals. I to the seventh is I times I to the sixth. Now, why are these true? Why is I times I to the sixth? Why is that I to the seventh? Well, because we are based on the powers of exponents. If you have the same bases, then you combine them by adding the exponents. And if there's nothing on top of it, it's automatically a 1. So that I has a power of 1. 1 plus 6 is 7. That's how I'm getting all these numbers. So back to this. I to the sixth was -1. So that becomes I times -1 is negative I. I to the eighth is I times I to the seventh. I times negative I makes it negative I squared. Negative I squared is -1. Okay, we're seeing a pattern now, as I am. The pattern is this. We have I squared is -1. I cubed is negative I. I to the fourth is 1. I to the fifth is I. I to the sixth is -1. I to the seventh is negative I, and I to the eighth is 1. They're repeating themselves in groups of 4, which is what we wanted to find out, if there is a pattern repeating. And the easiest way to remember is just I, 1, and the middle 2 are negative. So it's like if you ran a race and you won, said, I won, and the middle 2 are negative. So how does that help us? Since these repeat in groups of 4, whatever our exponent is, take that number and divide by 4. So how many times is 4 going to 27? Well, 4 times 5 is 20. 4 times 6 is 24. Subtract them, you get 3. We're looking for the remainder. If the remainder is 1, 2, 3, or 0. If the remainder is 1, 2, 3, or 0, in other words, there is no remainder. If it's 1, it's I. If it's 2, it's -1. If it's 3, it's -I. And if it's 0, it's 1. Since our remainder is 3, this answer is the same thing as -I. So we just have to remember how they repeat themselves. I1, I1, middle two are negative. 1, 2, 3, 0. Those are remainders. So how about this next one on the examples? I37. Again, take the exponent, divide it by 4. How many times does 4 fit into 30? I'm not 34, 37. How many times does 4 fit into 37? Well, let's see. 9 times 4 is 36. So a remainder of 1. Since the remainder is 1, this one is the same thing as I. How about I of 75? So take 4. How many times that go into 75? 4 goes into 7 once. Subtract. 4 goes into 35. 4 times 9 is 36, so it has to be 8. 8 times 4 is 32, so the remainder is 3. Since the remainder is 3, this answer is -I. We'll do one more. I of 80. 4 goes into 80 20 times. The remainder is 0. Since the remainder is 0, the answer is 1. We're almost done. All we have left to do is division. All we have left to do is division. Now, there's situations with this. When we divide by a number, say 3 divided by 5i. To get rid of we cannot, okay, here's the note. You cannot have an I on the bottom. So we have to get rid of the I on the bottom. Since it's a monomial, since it's a single term, to get rid of that I, we multiply the top and bottom by I. So we have 3i on top, 5i squared on the bottom. Remember, whenever we have I squared, it just changes the sign in front of it. It becomes -1. So this answer is -3i over 5. Again, even if you have a binomial on top, 2 terms on top, to get rid of the I on the bottom, we multiply I top and bottom. So distribute. So it's 2i plus 5i squared divided by I times I is I squared. These I squared just change the signs of the numbers in front of it. So it becomes 2i minus 5, negative 3 on the bottom. So this, you can't have a negative on the bottom, so it goes on top. It changes. So it becomes negative 2i plus 5, which becomes, putting it in correct order. Remember, complex numbers have to be written in this order. Integer first and then complex number. So that's if we have a single term on the bottom. Now, the problem comes whenever we have a binomial on the bottom, when you have two terms. Whenever you want to get rid of the I, when it has two terms, we have to multiply by what's called the complex conjugate. The complex conjugate is simply this. If we had A plus BI, the complex conjugate of this is A minus BI. Just change the sign in front of your I term. Because I'll show you why that works. So in this one, the complex conjugate of that one would be 3 minus 5i over 3 minus 5i. So 2 times 3 is 6. Positive and negative is negative. 2 times 5 is 10i. 3 times 3 is 9. Positive and negative is a negative. 3 times 5 is 15i. Positive and positive is a positive. 5 times 3 is 15i. Positive and negative is a negative. 5 times 5 is 25. I squared. It's a lot of writing. I'm going to show you a shortcut in a second. Combine like terms. On the top, we have 6 minus 10i. On the bottom, the 15i and negative 15i cancel. So we have 9. This I squared changes that to a plus. So we have 6 minus 10i over 34. 25 plus 9. We're not done yet. It won't take, the computer won't take this as an answer because you can simplify this. 6 and 10 both have a 2 in common. So I factor out a 2. Does 2 go into 34? Yes, it goes in there 17 times. So your final answer is 3 minus 5i over 17. Okay, the hardest part is the extended part here, but here's a shortcut. Whenever you multiply by a complex conjugate, let's look at the one we just did. 3 plus 5i times 3 minus 5i. It became 9 plus 25. 9 plus 25, which became 34. Let's look at another one. 2 minus 3i, 2 plus 3i. The shortcut is this. The reason this is 9 is because we multiplied 3 times 3. So this is 3 squared. The second number, this is a difference of two squares, actually. The second number is, that's 5i. 5i times 5i is negative 25i squared. That changes it to be a positive 25. So all you have to do is shortcut, take the first term, square it, plus the second term. Take the first term, square it, plus the second term, square it. So we have 4 plus 9 equals 13. One minus I, 1 plus I. The first term. No, notice we don't, in this part here, we don't deal with anything with the i's. We just look at the numbers. So it's 2 squared and 3 squared and add them together. The reason we add them is because that negative, the I squared gets rid of the negative. So this is 1 squared. In front of the I is a 1, so it's 1 squared plus 1 squared equals 2. One more. Negative 5 plus 3i, negative 5 minus 3i. Take the first term, negative 5, square it, plus the second term, 3 and squared. Negative 5 squared is 25. 3 squared is 9. So that's a shortcut we use to multiply complex conjugates. So here's this one. 2 minus 5i divided by 1 minus 6i. We'll finish this one and then we'll call it a day so you guys can watch the Cowboy game. So the rule is we can't have i's on the bottom. Since we have a binomial, we have to multiply top and bottom by the conjugate. Conjugate is change the sign in front of the I term. So it's going to be 1 plus 6i. 1 plus 6i. On the bottom, we have complex conjugates. So we take the first term, square it, plus the second number, and square that. On the top, unfortunately, we have to work it all out. 2 times 1 is 2. Positive and positive is positive. 2 times 6, I. Negative times positive is negative. 5i times 1 is 5i. Negative times positive is negative. 5 times 6 is 30, I squared. Two plus 12i minus 5i plus 30. Because remember, the I squared changes the sign in front of it. 1 squared is 1. 6 squared is 36. 2 plus 30 is 32. Positive 12 minus 5 is 12 is bigger, so it's positive. 12 minus 5 is 7. I. 36 plus 1 is 37. And there's your answer. Simplified version of it. That's the end of that section. Now, since we have that covered, what we're going to do the rest of this chapter next week is we're going to start learning about quadratic equations, how to factor them, how to solve them, how to graph them. And we're going to look at all sorts of, and then look at the special terms of zeros and different formulas, using the quadratic formula, using the complete the square methods to solve these things. So now we're going to start in the more difficult stuff. So looking at our remainder of the course, we have next week, which is the week of Thanksgiving. We have the week after that, which is the first week of December. And since we don't have a final exam per se, remember, I'm going to take the average of your tests. I want to have that last Monday of the final exam week as the last lecture to finish up everything that we're missing. So you guys will have enough time to finish the rest of the course. It's just that we have everything done by the 11th, midnight of the 11th, right? Because that's the system closes because after that it starts the winter mini, which I have to have the grades in the next day or a day after. So it's very important to get all your work in by the end of that week. So I can't extend anything. Whatever's not done will have to be counted as zeros.
Okay.
All right. All right. So that's it for today.
Okay.
Hope I
Well,
didn't
thank
go
you.
too fast.
No,